I'm Amir.
I'm Herman.
And today we will be talking about three different forms of energy storage. We'll be talking about batteries, supercapacitors, and capacitors. So supercapacitors, they're a form of batteries that they charge stuff fast, and they charge fast and they release energy fast, but they don't hold a lot of energy. Then there's capacitors. Capacitors are the worst. They charge fast, but they don't charge as fast as supercapacitors. They also hold the least amount of energy out of all of them. So then we have normal batteries. So normal batteries, they charge the slowest out of all of these, but they hold the most energy. So these are important because in our day and age, we're dealing with global warming. And these are clean and efficient ways that do not emit carbon. So basically, when you use stuff like these, you help the environment. So these batteries are important. Carbon. So how supercapacitors work are you have two pieces of carbon, and then you have electrolytes. So the electrolytes contain electrons and ions. Ions are charged particles. So basically what happens is when you're doing nothing to them, they're just there. You have the electrons inside of the electrolytes. So the first step to charging the supercapacitors, you apply energy to them. Because when you apply energy to the supercapacitors, it forces the electrons to go towards the carbons on each side. Then you apply pressure. You apply pressure because you want to decrease the distance that the electrons have to go to get to the carbon. So the longer you hold it, the more amount of energy you're going to be able to store. So after this is where the discharge process starts. So all you have to do is you have to remove the power source, because when you remove the power source, the ions, they go back to their original locations. And when they go back to their original locations, they begin to produce their energy. So.
Okay, so I'm going to talk about the picture. First of all, we examined that this is a game of dodgeball, and this is a very good example because they've used the balls as electrons and showed how the capacitors charge them. So first of all, this is just a regular, nothing happens, it's uncharged. This is two different charges. This is current. The black ones are current and the white ones are voltage. And they're attracted to two different sides and then shot against the other side. On this is just normal when something is traveling across the circuit from just to the other side.
All right, so let's talk about the limits of this picture. So a couple things. Two important parts of a capacitor are that they charge and then they discharge as well. And here we can see that this is discharging and the electrons are flowing back and forth, but there's no impulse for these dodgeball players to charge. So maybe they could put like yell dodgeball and then everyone starts throwing the balls as an impulse. Any questions?
Okay, so I actually just want to give an idea for this and then let you guys talk another second about the picture. So first I want to clarify one thing, which I think was just said wrong because it was said wrong last week. So normal capacitors charge faster than supercapacitors, but they do have lower capacity. So supercapacitors are in the middle between normal capacitors and batteries in both rate and capacity. So I'd like you to think about the picture, and I could be wrong, certainly have been wrong before, assuming that the balls are ions and the different color balls are ions of different charges. So could you guys maybe say a few words about the picture? assuming that the black and the white balls might be positively and negatively charged ions.
Okay, so in a supercapacitor, when there is a charge applied to it, the ions switch, go opposite sides from each other. So at the top they'll be the negative, for example. At the bottom they'll be the positive, and so that's why there's two colors. One is positive, one is negative, and when they discharge, they mix back together evenly, and that's why they're throwing it back and forth.
Right, I got. Or your.
And the left side is a regular capacitor, and it only has one charge ion, which would be, I guess, electrons, which are negative. Any audience questions? Yeah. In a capacitor, capacitors and batteries are different, but the charges are even. The positive charge and the negative charges in the ions in the capacitor, supercapacitor, are even. So when they discharge, the capacitor is neutral, I guess.
Right, but I think part of the question is, the people look the same, implying that the nature of the positive side and the negative side is the same. In a battery, is the positive and negative side also the same?
For the supercapacitor, at least the reason why they look the same are because they're both carbons on each side, because the electrolytes are sandwiched between the carbon. And for the batteries, I'm not sure because the experiment was on supercapacitors.
By the way, it is capacitor, no capacitate. We got about half and half with everybody here. So, no tay. So actually, I will tell you that in batteries, the two sides are different. They're made of different materials. There's one up there. No, filming.
Dad?
One more thing about capacitors. There's lots of uses in the future for them, for places in like buses, for example. These capacitors charge really fast. So like, Teslas and stuff, they have to charge overnight. Electric cars charge overnight. Buses, for example, that use supercapacitors, they can charge in about 30 seconds, and then they just drive for maybe 5 minutes before they get to a bus stop where they charge again for 30 seconds. And that refills the supercapacitor to full juice, I guess. And that's one of the uses for a supercapacitor, because electric buses, if they stop at a bus stop to try and charge, it'll take a long time to get a little bit of power.